Hi there, welcome to this session. Today, we will go over a technical preview of LitmusChaos 2.0, the next major version release from the Litmus project. 2.0 provides several aids to practice chaos engineering in a simple and efficient manner, primarily through a centralized control plane called as the Litmus portal. The portal facilitates creation of chaos workflows, which are very similar to the reliability pipelines that you have already experienced and know about. It gives you a way to manage chaos across several clusters from a single management console or dashboard. In this discussion, I will demonstrate how you can create chaos workflows in a couple of different ways against sample microservice applications, and also show how you can visualize the impact of chaos. Along the way, we shall also look at a few other interesting features of this platform. So let's go ahead. Before we get started with execution of chaos workflows, let us take a look at the test bed that we are going to make use of for this demonstration. I have a multi-node Kubernetes cluster in which Litmus 2.0 has already been installed. You can see various deployments in the Litmus namespace. The ones with the checked boxes comprise the control plane or the Litmus portal, and the ones with the unchecked boxes comprise the agent infrastructure. The control plane helps with management of chaos. The chaos agents carry out the fault injection and the steady state validation. The agents are auto-magically installed on the cluster where the portal is installed. This enables you to quickly get started with chaos, but you could also register other clusters individually into the portal with only the agents running there. I also have another application, in fact, a microservices application called the Bank of Anthos running in the default namespace. We're going to inject fault, a network loss fault against the balance reader application to inhibit reading the balance on the banking application. We'll do that using the chaos workflow. I also have another application in the demo space namespace called as Hello Service, and I have set up monitoring of the Hello Service using a black box exporter, and we're going to use this application to tell us how you can verify SLOs and how you can observe the impact of chaos, how you can visualize metrics using the Litmus portal, rather Litmus 2.0. Let me go ahead and start with the first workflow. We will log in using the default credentials, admin and Litmus. We will be taken to the home page of the user, admin in my case. You can see some past workflow runs and some summary about the agents connected. The workflow page gives you a table of all the workflows that you've run in recent times and tells you the resilience score associated with these workflows, along with details about how many experiments were contained within the workflow, what agent carried out the workflow, etc. You could also create schedules for workflows. These are repetitive executions of a fault. You can create a new workflow by clicking on schedule a workflow, and there are several ways to construct a workflow or run them. And we will take a look at that in a bit. The other important aspect of the Litmus portal is the Chaos Hub. You can call this the integrated or the embedded Chaos Hub, which has several experiments within it. And when you construct a workflow, you can pick experiments from the Chaos Hub. The agent page tells you the different clusters connected to the portal. The self agent indicates the connection of the local cluster, the one on which the portal runs. It is automatically registered. You can choose to connect and disconnect agents from this page. The connection of a new agent is facilitated by a tool called LitmusCTL, which you can download and run as CLI in your own harness machines to register other clusters onto the portal. The analytics page gives you details of resilience scores of past workflows, details of how many tests passed or how many experiments passed within a workflow, and other details. You can also use this dashboard, the analytics page, to add application dashboards very similar to Grafana, but rendered using a different technology. And the data sources for these app dashboards is typically Prometheus. You can connect that using add a data source option. The settings page allows you to modify your account details, create teams to collaborate on chaos, add users of various types, owners, editors, viewers that are going to be part of your team. It also has an option to enable GitOps and ensure that all the workflows constructed using the Litmus portal are committed onto a Git repository, thereby ensuring a single source of truth for all your chaos artifacts. You also have the option to change or manipulate the image registry for all the images used within a workflow. This is especially useful if you're operating in an air-gapped environment or have enterprise registries that you use. Let us go ahead and create our first workflow. We are going to create network loss on the balance reader application of Bank of Anthos. For this, we select one of these options to create a workflow from the embedded chaos hub. Let me call it Bank of Anthos. I'm going to select new experiment, in this case, network loss. We are going to tune this to select the right application. I'm interested in the balance reader, and I know that it's of kind deployment and resides within the default namespace. So let me go ahead and finish this. I am going to disable reverting of chaos at the end. That is, if I have this selected, it means it's going to remove the chaos engine at the end of the experiment. Having it as false leaves the chaos resources on the cluster so that we can take a look at its logs from within the portal. Let me select next. This step is a way for you to provide the weight or points for an experiment, indicative of its criticality. Typically, workflows comprise several experiments, and you can provide weights according to their relevance. And in turn, this is going to influence the resilience score allotted to a chaos workflow. I click next and choose to schedule this workflow right away. Instead of repeating it, I want to run this once and now. So let me go ahead and take a look at the YAML that is generated. You're familiar with the workflow kind. It has a couple of steps: to install experiments, to pull the experiment template from the hub and install it, next to launch the chaos engine. The chaos engine is of relevance here, and you can see that we are targeting the balance reader application with network loss for a duration of 60 seconds. Let me finish the workflow wizard, and I will see a new workflow getting created The workflow status can be tracked and visualized through the workflow visualization graph. At this point, the step to pull the experiment template from the hub and install it is being run. Eventually, you will see the chaos engine launched, the pod network loss being effected. The Bank of Anthos, as you can see, the sample banking application in which they can deposit funds and make payments. And this looks great at this point. But shortly after the experiment starts, you will see the balance cannot be read. And that's pretty bad. You cannot make payments because to make payments, you need to know, the service needs to know what is the balance, but the balance cannot be read. And as a user, you cannot read balance, though you deposit funds. We've deliberately ensured that there is no resilience built into this application, the way we've deployed it, to show the impact of chaos. You know that the Litmus experiment carries out a set of pre-checks to see if the application is in good state before it can carry out the chaos. So let us go ahead and refresh the application to see if the experiment has started. Let's log in. You can see that the balance cannot be read. And if I attempt to make a payment, the operation fails because you cannot read the balance. However, I can still make a deposit that might be successful, but you cannot read the balance here. These kind of quasi-operational states of applications can cause a lot of impact, negative impact at the user end, and you would dearly want to avoid this. Once this experiment runs its course, 60 seconds is the duration. We're going to do a post-chaos check as part of the experiment to see if all services are active and running. So you should be able to see in a short while the application return to good state, and you should be able to read the balance henceforth. We're still not through with the chaos duration, so let's wait for a few seconds more. Once the post-chaos check is completed, the workflow will complete. You will be able to make use of the portal to see the logs of the experiment thus ran, as well as you will also be able to see the chaos result. You're aware of the chaos result resource that carries status of your test and the verdict of the experiment. So you will be able to visualize that on the portal too. So let us verify the application gets back to good state. Yes, it does. The experiment has finished with the injection, and it will shortly complete the post-chaos checks as well. As you may have noted, in this experiment run, we have not defined any probes. In other words, we have not added any steady state hypothesis validation intent within the chaos engine, which is why the experiment shows that it has succeeded and the verdict is pass. This is the logs and this is the chaos result. What this means is that without validation intent specified within the chaos engine, the success of the experiment depends purely upon the success of the injection itself. The fault was injected and reverted successfully, which gives its verdict as pass. I hope this gave you a quick understanding of how to create new workflows using the portal and run them. The next example is to see how you can use predefined templates to launch chaos. In this workflow run, I am going to effect a pod delete against the potato head service. There is a single replica of this application running, so it's going to go down. As part of this run, I also have defined a probe, an HTTP probe to be precise. to continuously ping or probe for the availability of the service. We're going to do this with a polling interval of 1 second, along with a few retries built into the probe. Obviously, the probe is going to fail because it takes some time for this pod to be rescheduled, maybe on the same node, on a different node. And that is sufficient time for it to be inaccessible and for the probe to fail. Using this workflow, we will also show you how you can use pre-existing templates. The last time we ran a workflow, we used the My Hub or the embedded chaos hub to pick experiments and construct a workflow. This time, we're going to make use of a workflow which has been templatized from a previous workflow run. So I could go to a workflow, say templatize this, and then you will have a clone to work with. Let me select the potato kill with HTTP probe. That's the name of the template. It has a pre-filled name and description. And it also has the experiment tuned to act on the Hello Service application in demo space namespace. I give it all points. I schedule it now. Let me take a look at the YAML file, the chaos engine in particular. You can see that I have a probe defined here. It's called as the potato head availability check. And it has probe polling interval of 1 second and expects a 200 OK response whenever it hits this service endpoint. Let me finish. Take a look at the workflow. It's going to pull the experiment first and then launch the chaos engine, as we saw in the previous case. I also have a Grafana dashboard for the potato head application. And I'm going to get metrics from Prometheus. The black box exporter is giving me all the details about access and operational characteristics of potato head, along with the Litmus metrics. I have a dashboard here in which there is a Litmus chaos annotation present. It basically tells you the period when the chaos is active. You can see that the potato head application is always alive. It is 100% available, and it has an access duration that hovers around 15 to 16 milliseconds. I have set thresholds for both these metrics, and you can treat the probe success percentage and access duration as service level indicators, and the cutoff against them as SLOs. You can see this red area in the graph that is caused by the Grafana annotation, which in turn is picking details from a Litmus Prometheus metric. You can see there are a lot of Litmus metrics that we can make use of. Because we have a single replica, the availability drops below the threshold and the access duration just shoots up. These are not good things to happen. Maybe you need more replicas. You need a better deployment strategy to maintain your SLOs. Through this example, we would like to draw your attention to the exporter within Litmus and how you can make use of it to visualize chaos, and the probes within Litmus that you can make use of to add validation along with fault injection within an experiment. This time, the verdict of the experiment is expected to be fail, not pass, because we failed the constraint with respect to this application for it to be available all the time. You can see that the service has recovered, the pod has been rescheduled. We've finished with our iterations of pod delete of the Hello World application. The Hello service will be back. And as expected, the workflow failed. The logs give you the information about the probe that has failed. The chaos result tells you as much and wishes you better luck next time. The probe success percentage is the success factor of the experiment. You could have more than one probe, some of which may pass, some of which may fail. And the value that you get here, which is the ratio of the passed probes versus the total probes, is then going to be taken in conjunction with the weight or criticality that you provided this experiment within the workflow. All this is going to be factored in while creating the resilience score that you get at the end of the workflow. You can take a look at the workflow statistics. We have run these experiments over a period of time. I've just selected all the experiments here and I click compare. You will be able to see the score changing for all these workflows. This way you can verify the resilience. You can verify how your application responds to a particular scenario across infrastructure, across releases and builds, and track your resilience journey. I hope this gave you a quick idea of the functionality and operations in LitmusChaos 2.0. Do give it a try, and I look forward to talk more about this with you in future. Cheers.